One of the most fundamental contradictions of this system is the accelerating soil erosion. Okay, so soil is lost at much greater rates than it is regenerated in systems of industrial production. So people who champion the huge yield gains that have been made in industrial monoculture production, and there have been phenomenal yield gains, they often leave out the fact that those yield gains, one of the things they hinge on fundamentally is phenomenal growth of fertilizers. So the loss of soil is sometimes referred to as soil mining, because nutrients are being depleted and not regenerated in systems of industrial monoculture production. So how is that problem resolved? Well, it's never resolved. Industrial monocultures have not fixed the problem of soil degradation. They've basically overridden it with continual inputs of principally three fertilizers: nitrogen, potassium, and phosphorus fertilizer. The NPK fertilizers are the dominant sources of soil fertilization on a world scale. And the production and movement of fertilizers entails an enormous energy budget. Okay, the synthetic nitrogen fertilizer is very resource intensive, very energy intensive in the manufacture, and often moved over significant spaces. There's an energy budget there. The mining of phosphorus and potassium fertilizer has an energy budget in the mining, the processing, and often the movement over large spaces. So there is a tremendous amount of energy embedded in managing soils of industrial monocultures. Okay, people often don't think about just how much energy goes into the managing soils in our food system. And this is a fundamental part of our food system, is the energy that goes into the manufacture and the movement of fertilizer. So again, this problem is never solved, but it's overridden through with a very resource-intensive systems of fertilization. Another problem that's never resolved in industrial monocultures is the increased vulnerability to pests. So when huge landscapes are given to a small number of crops, there is a greater vulnerability to pests. And by pests here, I'm talking about weeds and insects and fungus, and so there's both this what I call an expanded vulnerability to pest threats when landscapes are specialized, and there's also an expanded definition of what are the problem, so because monocultures really want only one thing to grow. And so this is another fundamental part of industrial monoculture production, is the massive growth in pesticide consumption. So in industrial monocultures, there has been roughly a threefold increase in yield, so the amount of product coming out of individual plants, which is a phenomenal gain. There's no denying that yield gains have not been phenomenal over the past 60 or 70 years. But underpinning those yield gains of about a factor of 3 are more than a 10-fold increase in pesticide consumption and more than a 10-fold increase in fertilizer consumption. And again, in the manufacture and the movement of fertilizers and pesticides, there is an enormous resource budget. And there's also downstream costs of those fertilizers and pesticides in many, many ways. So that's a very important part of understanding the resource budgets and pollution loads of this system as a whole, is the story of pesticides. And the pesticide story also, this 10-fold or so increase of pesticide consumption on a world scale, also ties to the declining soil health. So industrial monocultures are very, they tend to increase the loss of soil nutrients based on how landscapes are specialized and huge level areas of bare ground between planted rows. Well, also the huge proliferation of chemicals is responsible for the declining soil health as well. The high-yielding seeds that have brought those great yield gains that I'd mentioned are also dependent upon increasing water consumption. And so industrial monocultures are sometimes described as being thirstier than crops grown in mixed farming systems. So there are these drier soils in industrial monocultures, and then also seeds to get those big yield gains depend on a lot more water. And so that's been described as thirstier seeds. And so these systems of industrial monoculture production are tied to massive expansions in irrigation on a world scale. And that ties to resource budgets, both in terms of the pull of water from lakes and rivers, but also in some cases fossil energy, pumping water against gravity, both from sometimes from lakes and rivers, and in many cases from underground reservoirs. So a very large area of the US West is tied fundamentally to an underground aquifer that is not regenerating, the Ogallala Aquifer, which waters a huge area of the US High Plains and makes it productive. So there's this increased irrigation budget as well. And these problems are never fundamentally resolved. The soil degradation, the increased vulnerability to pests, the increased water demands, they're never fundamentally resolved. They are continually overridden through continual applications of fertilizers, pesticides, water that are a fundamental part of the continuing productivity of these environments. And then another aspect of that's a fundamental part of this biological simplification is that when huge areas of landscape are given to a small number of things, food necessarily must move much farther. So in the case of the U.S., that we have a whole area that's called the wheat belt, another area that's called the corn belt. When you have biological simplification and standardization on a massive scale, it necessitates the movement of things over longer spaces. And so there's this need for expanded energy in the movement of things over space. And so that's another part of this overall energy and resource intensity. And so sometimes people have described this as food miles, that the average item of food in North America travels, some estimates are as many as 1,500 miles from land to mouth. And so there's this energy budget in the movement of food. And there's the energy budget also in the movement of inputs into farm systems. Okay, so everywhere there is this dependence upon fossil energy in the machinery, fossil energy in the fertilizer manufacturing movement, fossil energy in the petrochemical derivatives of the pesticides, fossil energy in the movement of pesticides and the application of pesticides, lots of fossil energy in the irrigation pumping, fossil energy in the movement of things over greater space. And so there's a quote from Brett Clark and Richard York: modern agriculture has become the art of turning oil into food. Fossil energy permeates our industrial monocultures, and it's something that people often think very little about. Michael Pollan had once famously estimated that there are about 10 calories of oil embedded in 1 calorie of industrial food. Now that's an incredibly complex calculation, but it speaks to how deeply oil is embedded in industrial food production, again, from the machineries, the fertilizers, the pesticides, the irrigation, and the movement over greater distances. And all of this deep fossil energy dependence, all of this is just speaking here on the side of monoculture production. And this has an array of ecological costs. It's part of the story of a big part of the story of greenhouse gas emissions is related to this big energy budget. Fertilizers are also a major source of nitrous oxide emissions. And so this story, modern agriculture has become the art of turning oil into food, is a big part of the overall climate impacts of industrial agriculture.